Assalamu alaikum guys, welcome to part 2 of trigonometry A2 level. So in this video, I know my screen looks a bit different, but yeah, it's a good kind of different. So anyways, in this video, we are going to study trigonometric identities. Let me just write it down. 1 second, guys. Um, yes, okay. Trigonometric identities. So in this lesson, we are going to study three types of identities. Number one, basic trigonometric identities. Number two, compound angle identities. Compound angle identities. And number three, double angle identities. Double angle identities. As much as I hate to say this, but the identities we are going to study under each of the mentioned headings, you will have to learn them by heart. There is no escaping it. So let's start off with basic trigonometric identities. Okay. Basic trigonometric identities. Okay. So we have number one, sine square theta plus cos square theta is equal to 1. And by the way, the stuff which I'm writing with white is equal to identities. All right. And anything else is just an explanation or rearranging stuff. Okay. So the stuff in white, those are the identities which you have to learn by heart. Okay. Let me just solve with yellow. So sine square plus cos square theta is equal to 1 can be rewritten as sine square theta is equal to 1 minus cos square theta, or maybe cos square theta is equal to 1 minus sine square theta. All right. So we have number two, we have sec square theta minus tan square theta is equal to 1. This can be rewritten as sec square theta is equal to 1 plus tan square theta, or it can be written as tan square theta is equal to sec square theta minus 1. And number three, we have cosec square theta minus cot square theta is equal to 1. This can be rewritten as cosec square theta is equal to 1 plus cot square theta, or cot square theta is equal to cosec square theta minus 1. And by the way, this you must have studied this identity in AS. These two and a list of more identities, which we are going to study later, are all new, which you have to learn once again. Okay. So let me just write some basic identities, some other basic identities as well. You must know tan theta is equal to sine theta upon cos theta. Cosec theta is equal to 1 upon sine theta, and sec theta is equal to 1 upon cos theta, and cot theta is either equal to 1 upon tan theta, or cot theta is equal to cos theta upon sine theta. So it pretty much depends on the question whether this one is being applied or this one is being applied. So you have to check both sometimes. All right. So for your easiness, the stuff in white, you have to learn those identities by heart. And yellow is just rearranging them. So yeah, that's pretty much self-explanatory. Okay. So let's do some example of these. All right. 1 second, please. Yes. Okay. So we have a question which says, prove that a sec square theta minus tan square theta is equal to 1, and b is cosec square theta minus cot square theta is equal to 1. So basically we have to prove the identities we just wrote above. So let's just prove it. Okay. So what we know is that 1 upon sec square theta is equal to 1 cos square theta, and tan square theta can be written as sine square theta upon cos square theta, and that is equal to 1. All right. And cos square theta, 1 minus sine square theta. Now notice that 1 minus sine square theta is the same thing as cos square theta. It is simply, the question is simply rearranging this. Okay. So we can write 1 minus sine square theta as cos square theta. Cos square theta over cos square theta cancels out, and this is equal to 1, thus proven. King. Yeah. So let's head over to another identity, which we have to prove. Okay. Cosec square theta minus cot square theta is equal to 1. So we know that cosec square theta is equal to 1 upon sine square theta, and cot square theta is equal to cos square theta upon sine square theta, and it is equal to 1. Sine square theta, 1 minus cos square theta. All right. So what is 1 minus cos square theta again? It is simply rearranging this identity. All right. So 1 minus cos square theta is sine square theta. Sine square theta upon sine square theta. It cancels out, and the answer is 1, and thus we have proven it. And we can make our crown again. All right. So yes, that is part 1 with basic trigonometric identities. Now let's jump over to compound angle identities. I hope everything studied here is crystal clear. Okay. Now compound angle identity. Okay, so compound angle identities. Again, what I'm writing with white, that is stuff you have to learn by heart, right? Remember that sine A plus B is equal to sine A cos B plus cos A sine B plus cos A sine B. Okay. And similarly, sine A minus B is equal to sine A cos B minus cos A sine B. Now, cos A plus B is equal to cos A cos B minus sine A sine B. And cos A minus B is the opposite, which is cos A cos B plus sine A sine B. Now we have tan. Tan A plus B is equal to tan A plus tan B upon 1 minus tan A tan B. 1 minus tan A tan B. And tan A minus B is tan A minus tan B upon 1 on 1 plus tan A tan B. So this is sine, this is cos, and this is tan. With, I know you cannot just learn it uh, as it is as of yet, but with practice and practice and practice, once you will surely get the hang of it. In the starting questions, when you are like solving new questions, we're just solving questions. It would be difficult, but with these identities written in front of you, you will surely get the hang of it, and you will for sure remember it. So again, it only requires practice and a lot of practice. Okay. So we are going to do a question. Wait. Prove that A tan A plus B is equal to tan A plus tan B upon 1 minus tan A tan B. Okay. So we have to basically prove this identity. Okay. So let me just prove it to you. We know that tan A plus B is equal to tan is sine over cos, all right, sine A plus B upon cos A plus B, all right, and sine A plus B is, as we studied here, sine A plus B is sine A cos B plus cos A sine B. Sine A cos B plus cos A sin B. All right, and cos A plus B is cos A plus B is cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B. Now notice one thing. Notice that this identity cannot be solved further. All right. So what we are going to do is we are going to divide the whole expression, divide the whole expression by cos A cos B. Now let's just do that and see what happens. Sin A cos B upon cos A cos B and plus cos A sin B upon cos A cos B, and the whole thing, this part, cos A cos B upon cos A cos B minus sin A sin B upon cos A cos B. By doing this, we got rid of this and this cancels out, this and this cancels out, this and this, sorry, uh, nothing cancels out here. All right. So this leads to, we are left with sin A upon cos A plus 1. All right. Sin A upon cos A plus 1 and 1 minus sin A sin B upon cos A cos B. Yeah, so my bad here. Uh, this doesn't cancel out. Wait. Yeah, only this cancels out. I don't know why I couldn't see it. Yeah, but this and this cancels out, not this. Okay. So here we are left with sin A sin B upon cos B. Okay. Sin A upon cos A is what? Tan A. And sin B upon cos B is tan B upon 1 minus sin A sin B upon cos A cos B, which is tan A tan B. And this is exactly what we had to show. All right. This is what we had to show. Okay. So these are compound angle identities which you have to learn by heart. Moving on. Moving on, we have double angle identities. And by the way, we are going to do practice as well. I'm in another video, part 3 of this video precisely. In this video, I'm just going to cover up the major concepts, which are basic trigonometric identity, compound angle identity, and double angle identity. In the next video, we are going to start off by solving some questions of these, and then we are going to move on to harmonic identities and trigonometric graphs, and I think that's it. I will double check, and that would be the end of A2 trigonometry. So yeah, double angle identities for you, part 3. Double angle identity. Double angle identity. Again, with white, I'm going to write stuff that you have to learn by heart. Sine 2a is the same thing as 2 sine a cos a. Now this can be rewritten as sine a plus a, which is 2a. Sine 2a is sine a cos a plus cos a sine a. Sine a cos a, which is 2 sine a cos a. Okay, which is the same thing as this. All right. Next up, we have cos 2a. Cos 2a is cos square a minus sine square a. All right. And this is also equal to 1 minus 2 sine square a, or 2 cos square a minus 1. All right. So you have to learn this as well. And uh, all three of these lines, all three of them are equivalent to this, because let's say if you expand cos square a, you get one. Let me just show it to you. I think that would be better. If you write like expand cos square a, you will get, since sine square plus cos square is equal to 1, you will get 1 minus sine square a. All right. And let's just say 1 minus sine square a minus sine square a is equal to 1 minus 2 sine square a, which is this. All right. Now, similarly, instead, if you choose to expand sine square a, let's say we expand sine square a, we get sine square a 1 minus cos square a, right? Now, cos square a minus sine square a, which is 1 minus cos square a, cos square a minus 1 minus minus plus cos square a, we get 2 cos square a minus 1, which is this. All right. So these are basically three versions of the same thing. And I would recommend you to learn it by heart, because in the exam, you don't have this much time to figure stuff out. All right. So yeah, now cos a plus a, this could also be written as cos a plus a, all right, which is cos a cos a minus sin a cos square a minus sin square a. All right. So you have to learn them by heart. There is no other option. Now, another identity. Tan 2a is equal to, is the same thing as tan a plus a, and we have studied this, right? Tan a plus a is equal to tan a plus tan a, 1 minus tan a tan a. So it's going to be pretty much the same thing here. So yes, This is equal to tan A plus tan A upon 1 minus tan A tan A, which is 2 tan A upon 1 minus tan square A. All right, so you can just remember that tan 2A is 2 tan A upon 1 minus tan square. Or you can do this working as well, but again, I said there is not much time in the exam. If you're okay with this, then go ahead with this. Otherwise, it's better to just learn this. Okay? These are double angle identities. And one thing I would like to mention here is that I know at this point these identities must be confusing you, but trust me, once you start solving questions, once you start doing questions of different varieties, different types, and as much practice as you do, you will surely get the hang of it. Trust the process. Do not lose hope now. I know they are intimidating. I know that they are difficult, but all you have to do is practice. And you will surely enjoy doing it once you get the hang of it, you will surely enjoy it. Okay? So yeah, so that's it. And yeah, that's it for now. And one more thing that I would like to just mention here is that these identities can be like twisted around. They can be written as, let's say, we know that uh, sine 2a is equal to 2 sine a cos a. So the question can also ask you what is sine for a. It would be 2 sine 2a cos 2a. And similarly, they can also ask you what is sine 6a. It will be 2 sine 3a and cos 3a. Similarly, sine 8a would be 2 sine 4a cos 4a. And at times, even though it is rare, it can also be asked what is sine a. It is 2 sine half a cos half a. So you can see how this goes around, right? One easy way to remember this is that if anything other than sine 2a, let's say sine 4a, the half of it gets here. Okay, let's say sine 6a, 2 sine 3a cos 3a. Sine 8a, 2 sine 4a. Half of it goes here and here. Okay, that's just an easy way of remembering it. Sine a, 2 sine half a cos half a. All right. So now just play around with cos as well. Cos 2a we studied equals cos square a minus sine square a. Now he can also ask you what is cos tan a. All right. So that would be half of 10, which is cos square 5a minus sine square 5a. All right. And let's say if he asks what is cos a, that would be cos square half a minus sine square half a. All right. So yeah, that is it for today. And I know this is just the content. And from the next part onwards, we will uh, start off with solving a lot of questions of these identities. And then we are going to jump over to harmonic and trigonometric graphs and other important stuff which you need to know. That's it. Thank you so much. Allah Hafiz.